This is the third video on section 6.1, tangent planes, linear approximations, and differentials. And in this video, we're going to focus on the differentials. And so again, what we're doing here is similar to what we did in Calculus 1, except we have a function of n variables and not just one. Each variable, x sub I, is incremented by a delta xi, as opposed to in Calculus 1 we just had x incremented by delta x. And then we have our change in z, our delta z. This is our function evaluated at the new values of the xi's minus the original f of x. This is our change in z. In Calc 1 we simply had delta y was f of x plus delta x minus f of x, so we just had a change in y. But here we have a function of n variables, and so we change each of those variables, presumably a little bit, and then that produces a change in z. And now we have our differentials, our delta x, our dxi's and our d sub z. And dz is the dependent variable. It depends on the dxi's. Those are the independent variables. And because they're independent, we can make them what we want. So we make them be the delta x sub i's, just like we did in Calc 1. We set dx to be delta x. Well, here we're going to set dxi to be delta xi. And then we define the differential dz in a similar way. We take the partial derivative with respect to the first variable, multiply by the dx1. And we do that for all of those, and we add those together until we get down to the last one. We take the partial derivative with respect to the last variable, evaluated at our point, times dx sub dx sub n. Now, just like in Calculus 1, in general, use a linear approximation to approximate a function value, and use a differential to approximate a change in a function value. So if we look at example 161, example 161 was simply to calculate the differentials of the previous examples. So we have z is f of xy, which is 2x squared y plus y cubed. We already calculated the partial derivatives. So the partial derivative with respect to x times dx plus the partial derivative with respect to y times dy. We calculated those partial derivatives in the previous videos. For part B, we have z, f of xy, is x times e to the xy. Partial derivative with respect to x times dx plus the partial derivative with respect to y times dy.